only where you have clock and the clock has suppose minute hand and hour hand. So the two hands make different angles with each other. So let's see here. The hands of a clock make different angles at different times. At 1 o'clock, the angle between the hands is 30 degree. Why? Okay, so basically in this case you will start with what is the measure of complete angle. Suppose I have a clock. Now when one and its center over here, so when your minute hand starts with 12 reading and turn and come back to 12, okay, like this. The minute hand is starting from 12 and coming back to 12. So what is the angle formed here? The angle formed is complete angle, and what is the measure of complete angle? It is 360 degree. So the complete rotation or turning of your minute hand gives you total of 360 degree. Okay, and how many lines do the clock have? How many lines? So what you have is 1 2 3 4 and then 5, 1 2 3 4 and then 5, like this your clock runs. So from each number to the next number, like you have 1 here suppose. So how many lines are there? 1 2 3 4 and fifth line is the 1, and then 1 2 3 4, fifth line is 2, then 1 2 3 4 and fifth line is 3. Like this your clock works. So it is asking that what is the angle between hour hand and minute hand when it is 1 o'clock. So leaving the question just like that, how many lines are there in between 12 and 1? There are 5 lines. 1 2 3 4 5. Then again 1 2 3 4 5. And we go from say 12 to 12. So total lines कितनी हो जाएंगी? How many lines would have? We would have 12 into 5. Okay, because you have 12 numbers here. 1 2 3 4 5 6 7 8 9 10 11 and 12. 12 numbers are here. So when you multiply it with 5 lines, you get total 60 lines are there. Okay, so 60 lines, and your okay, so 60 lines are there. Now what would be the measure of each line then? I have written something here. Measure of angle when minute line goes from one mark to another. Okay, what is the measure of angle of turning, you can say? What you are seeing here, both hour hand and minute hand are turning. Okay, they are taking one complete round. So what is the measure of one mark over the clock? So how would you find? There are 60 lines into angle of one mark, angle of one mark. Mark means this lines I am saying. So you can also write angle of one line. That is equal to, if you multiply 60 with angle of one line, then you get the total angle as 360 degree. Understand this question, that total there are 60 lines and total angle is 360. Total lines are 60 and total angle is, complete angle is 360 degree. So what is the measure of going from one line to another? This is 360 degree, divide by 60 degree, or you get 6 degree. Now measure of one line means this minute hand when goes to next line, you get the angle equal to 6 degree. Okay. Now how many lines are between when the clock is having 1 o'clock? It is asking the angle of 1 o'clock. So how many lines are there total? 1, 2, 3, 4, 5. So what would be the total angle of, or you write angle at 1 o'clock. Okay. Do you understand? Angle at 1 o'clock means when the clock is giving the time 1 o'clock. So where would be our hand? Our hand would be at 1 and minute hand would be at 12. So we would get angle between one line to another line is 6 degree and total there are 5 lines. So you get it as 30 degree. So you have to understand it repeatedly. You repeat this clip here and then you would understand what is the question. Question is that when it is 1 o'clock, what is the angle between two hands, minute hand and hour hand? So for calculating that, first you will find that what is the angle between two lines. There are total 60 lines in the clock. Why 60? Because you are going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So I just mark it here 4, 5, 6, 7, 8, 9, 10, 11. It is like this. Total reading is 12. The marking between two readings, that is 12 and 1 or 1 and 2. How many lines are there? There are 5 lines. So total lines becomes 12 into 5, that is 60 lines are there. Now, and what is the complete angle when the minute hand rotates, take one complete rotation. It goes from here to here, back. So that complete angle I have drawn over here for minute hand, that complete angle is 360 degree. So when you divide the complete angle with the total number of lines, you get angle for one line to another or two markings. So that is 6 degree you get here. And now it is asking what is the angle when the hour and minute hand is making the time 1 o'clock. So how many minute hand would be at 12 and hour hand would be at 1. So how many lines are there? 1, 2, 3, 4, 5. So you get 6 into 5 is equal to 30 degree. So the hands of a clock make different angles, and it has asked at 1 o'clock why it is 30 degree. So this is the first part. Then the second part is what will be the angle at 2 o'clock. Okay. What will be the angle at 2 o'clock? So let me just show you here. When the hour hand is at 2 o'clock. This is 2 o'clock. Okay, and now I will rub this 1 o'clock from here. How much is the angle? At 2 o'clock, our minute hand would be at 12. Our hour hand would be at 2. So, how many lines it has covered? These two rays. So, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So, there are total, you would say that at 2 o'clock, total lines are 10. Angle between two lines is equal to 6 degree. Therefore, total angle or angle at 2 o'clock is 6 into 10, that is 60 degree. So this is 60 degree. What would be the angle at 4 o'clock? So now you move your line or your hour hand at 4 o'clock. Your hour hand is at 4 o'clock. Now let us rub this 2 o'clock from here. So this is your 4 o'clock. How many lines are there now? How many lines are there? There is 5, 10, 15 and 20. So at 4 o'clock, total lines are 20. Angle is 6 degree. So you get it as, multiply it 20 with the degree between two lines and you get as 120 degree. What is the angle at 6 o'clock? Now when the clock reaches 6 o'clock. Now here, this is 6 here, this is 12 here. What is the type of line you are getting? This you can only tell while observing the figure here. This is a straight line now. The one ray is minute hand, this is your hour hand. So this is a straight angle. And you get, what is the measure of straight angle? You get the straight angle as 180 degree. So it's your choice. You can directly write at 6 o'clock it is a straight angle and measure is it is 180 degree. So with this our part B finishes off. So part C is explore other angles made by the hands of clock. So we can take any other, say it goes to 9. Your hour hand goes to 9 o'clock. Now in this case, what is the angle between your hour hand and minute hand? Now the hour hand has moved to left side. So you can also say that it is making L shape. So this is 90 degree. So at 9 o'clock, this is again a very observable or known figure that you are getting a mirror image of L. So you get at 9 o'clock it is 90 degree. You can also write the reason because it is making L shape. So that's it for this question. So this is the first part where you see angles, that is your wall clock or wristwatch or any watch that has minute hand and hour hand. So this is the first observation in your surrounding. Second observation in the second question, let's see the angle of a door. So when you open the door or close the door, the angle changes. The angle changes. So the question is it possible to express the amount by which a door is opened using an angle? What will be the vertex of angle and what will be the arm of angle? So when the door is, say you have one door of your classroom, when the door is fully open, what is the shape of door? Can you tell? Like this is your it is like this. So when the door is fully open, this is the way to enter. When the door is fully open, what is the shape? Its shape is L. So you can say that when the door is fully open, the angle is 90 degree. So question number 2A, when the door is fully open, it is L shape. Well, it is for classroom area. I am talking about for classroom area. It is L shape and you get the measure as 90 degree. That is 90 degree. Now suppose you are going outdoor. What is the vertex? Vertex is the hinges connected to the wall. Do you know what are hinges connected to the wall? There are screws that are there in the, you can also say screws that are connected to the wall and that are connected between door and wall. Okay, so when screws connected between door and wall act as vertex. See it in your classroom area. And what will be the arm of the angle? So one arm is door itself, arms of angle, door itself, and other would be the way to come in or go out. So this is the question. You can also measure angle with the wall in case one arm is taken as wall. Then what will happen? When door is fully closed, what will be the angle? Suppose this is your wall and this is your door closed. So what would be the angle between these two? It will be, angle is 90 degree. When the door is fully closed, this is wall and this is door. This is wall and this is door, yes. So when the door is closed, the angle becomes 90 degree. Okay, and when the door is fully opened, the angle between door and wall is 0 degree. Why? Because when you bring the door fully open, it will overlap with the wall only. So the angle would be 0. So this is how you can see angles. Then question number 3, Vidya is enjoying her time on the swing. She notices the greater the angle with which she starts the swinging, the greater is the speed she achieves on her swing. But where is the angle? So this is an obvious question now. You must have seen the swing. The swing has, let's say this is the swing. Swing goes forward or swing goes backward. So from the original position, wait a minute. This is the swing. It is straight at this moment. If the swing comes forward, there is an angle formed between the original position. if the swing goes backward, then also it makes the angle. So here the rotation is in the forward direction and here the rotation is backward direction, and this is the vertical position of the swing. So with this I think, okay, there are some other questions also. Question number 4. Here is a toy with slanting slabs attached to its side. Greater the angle or slope of the slab, faster the balls can roll. Can angles be used to describe the slope of the slab? So yes, angles can be used to describe the slope of the slab. It is saying that this is the slab, then the slab angle changes, then the slab angle again changes, then the slab angle again changes. It is like this. And how the slab angle would affect the ball rolling over it. Okay, so the slanter, if the slab is less slanting, then the speed would be less. Question number 4. If the slant of slab is less, speed of ball would be less. And if slant of slab is more, speed of ball is more. If the slant of slab is, you can say, steep, speed of ball is more. So this is how the question is. What is meant by steep? If I draw a line over here, a line like this is more steeper than a line like this. Okay, so slanting, more the slant or more steep the slab, more would be the speed of the ball falling down, and less is the steep, then it would be, speed of the ball would be less. So this is question 4. Then question 5. All these questions are based on the visibility of angles in our surroundings. Like first question was wall clocks, second question was door opening and closing, then third is the swing, fourth one is a game or a toy, and now the fifth question, observe the images below where there is an insect and its rotated version. Can angles be used to describe the amount of rotation? So yes, and it can be used. So horizontal line, hint is given, horizontal line touching the insects is the one arm of angle. What will be the arm of the angle and the vertex? Vertex would be the insect itself. So question number 5, vertex is insect original position vertex would be insect itself, and arms are horizontal line, and again the second arm is insect himself, insect's position. So these are some sort of familiar examples in the surrounding. So with this we finish off with the class today. We leave it here, and from tomorrow we will start with the drawing angles. So drawing angles means it would be opposite of the what we were doing up till now. Angles were given, we were measuring. Now the measure of angle would be given, and you have to draw the angle using protractor. So this we would continue in the next class. So have a nice day. Take care, students. Bye.